Hello students, in this video we are going to discuss the nomenclature of aldehyde and ketones. So as already you are familiar with the some of the rules which need to follow while naming the organic compound. So this table will help you to identify the prefix and suffix for the important functional group like carboxylic acid. It is the more priority should be given to carboxylic acid. So here the arrow mark shows the increasing priority. So carboxylic acids have greater priority and it is used, its suffix here it is oic acid. If a carboxylic acid and aldehyde groups are present in an organic compound, then we have to give more importance to carboxylic acid. And if aldehyde and ketone groups are present in an organic compound, then we have to give more preference to aldehyde. So at the time the ketone group act as a substitute there, in which we have to name the prefix as oxo. But when the ketonic group is acting as a functional group, then we have to use the suffix one. So these are the basic suffix and prefix for the important organic compound, as we have already discussed in 11th standard. So now let us discuss some IUPAC naming for the some important organic compound, that is aldehyde and ketones. Here we have the three examples, that is methanol, ethanol and 2-bromopropanol. Here it's very simple, that is in this only have one functional group, that is aldehyde group, which is marked with it is shaded with yellow color. So this group is actually the aldehyde group, and because the aldehyde group having the carbon, therefore it should be included in the chain, in the main chain, and we have to start the counting from the number 1 carbon should be this carbon. So we'll be naming on the basis of this. Here only one carbon is there, therefore we'll be using the word root here meth, and Al is the primary, that is the suffix for a functional group aldehyde. So the name will be methanol. Formaldehyde is a common name for this compound. Now in the second case, here the aldehyde group is CHO, and here there is an alkyl group methyl. So total number of carbon is 2, because aldehyde group carbon should be included in the chain. So here 2 number of carbon atoms are there, therefore its name is ethanol, where eth is the word root which showing the number of carbon atom in the main chain. Now when you look at the third example, in the third example here the aldehyde group is present, that is the first carbon, and this one is the second carbon, and this is the third carbon. So total 3 number of carbon atoms are there, and as here the functional group is aldehyde, so you need to start the counting from the group, that is the functional group aldehyde. So that carbon will be the first carbon. So here there is one substitute, that is Br, which is on the second carbon. So what will be the prefix here? Prefix, the naming of substitute, that is 2-bromo. Position is also important, 2-bromo, and the number of carbon atoms in the word root is 3, therefore prop, and the functional group is aldehyde, therefore Al. So propanal. So that is the name for 2-bromopropanol. That is the name for this organic compound. So we'll be using such rules in order to name the organic compound. But if the functional group having an aldehyde group is present on the cyclic compound, like this example, here the aldehyde group is present, that is attached to one of the carbon atom of benzene ring. Therefore it is named as benzene carbaldehyde, or in simple words we name usually as benzaldehyde. In the second example here, that is the aldehyde group is attached to a cyclic compound, that is not a benzene ring, because it does not have alternate double and single bond. It is called as a cyclohexane. So whenever the aldehyde group is attached to a cyclic part or the cyclic alkyl group, then we use the word carbaldehyde. As here the number 1, it should be given to this one. So here we cannot include this in a continuous chain. So that's why we have to use this in the main chain. But in the main chain, because of the cyclic one, it cannot be included. So how we can name such type of aldehyde? That is just by naming the cyclic part, and then we'll be using the word carbaldehyde. So the name of this compound is cyclohexane carbaldehyde. The same type of naming is applicable for this also. Here this one is benzene and this one is an aldehyde group. So that is cyclic part and the aldehyde group. So we'll be using the word, the name for the cyclic compound, that is benzene, and for aldehyde carbaldehyde. So in short, we'll be using the word benzaldehyde for this. The next example here, in this as it is given, we have to first identify the functional group. So which one is the functional group here? That is this is the functional group, that is aldehyde group is the functional group, and here there is one substitute, that is Br, and here there is one substitute, that is methyl group. As the aldehyde group is the functional group, so we need to number from here 1. This is the first carbon, because there is no other functional group in this one. So this aldehyde carbon should be the first carbon. This one is the second, then this one is the third, 4, 5, 6 and 7 carbon. So total 7 carbon atoms are there. So what will be the word root here? The word root will be hept. Hept is the word root. Now what about the substitute here? Here which substitutes are there? There is one bromo, that is on the 4th carbon, and there is one methyl, that is on the 3rd carbon, but alphabetically ordered bromo and methyl. Which one should come first? That is alphabetically B comes first. Therefore first we have to name bromo, that is on the 4th position. Therefore it is named as 4-bromo, and the methyl group is on the 3rd carbon, that is the 3rd carbon, so it is named as 3-methyl, and the number of carbon atom in the word root, that is here, this is the main chain. This is the main chain that having 7 carbon atoms. Therefore we'll be using the word hept, and because here there is one aldehyde group, that is a functional group, so we'll be using the suffix that is -al. So that is the name for this compound is 4-bromo 3-methyl heptanal. Here we have to give importance to the functional group, so the counting should be start from here, even though it is farer or nearer to the functional group. If the substitute are closer or farer, but still we have to give the counting from the functional group. Now next example, it is also a cyclic part. As I told you, whenever there is a cyclic ring and the aldehyde group is attached to that cyclic ring, in that type we have to use the functional group aldehyde. Here we can represent by carbaldehyde. Since here 2 aldehyde groups are there, therefore we will be using the word dicarbaldehyde, that is on the 1st and the 2nd carbon atom of the benzene ring. This is a benzene ring, and one aldehyde group is attached on the 1st carbon and the other one is on the 2nd carbon. Therefore it is named as benzene 1,2-dicarbaldehyde. So it is important for a cyclic compound, we have to represent the aldehyde as carbaldehyde. When the aldehyde group is attached directly to the cyclic part, then only we'll be using the word carbaldehyde. Now in some of the compound, like an open chain compound but have two functional group, that is a two aldehyde group is present. That is, here is one aldehyde group and here there is one aldehyde group. So two aldehyde group are there and it is in open chain structure. So how we have to name such cases? In that case, we'll not be using carbaldehyde word, we'll be using the suffix al. But here two aldehyde groups are there, therefore we will be naming it as dial, because here total number of carbon atom in the main chain, when we count it here in the main chain, how many number of carbon atoms are there? That is, here both the aldehyde we have to count it, because aldehyde group carbon should be included in the main chain. So this is the first carbon, second, third, 4, 5. Total 5 carbons are there. So we'll be using the word wrote pent, and all are single bonded between the carbon atoms. Therefore we'll be using primary suffix, that is an, and the secondary suffix, that is a functional group aldehyde, and its suffix is al. So here two aldehyde groups are there, therefore we'll be using the word dial. Now why it is number as 1 and 5? Because it is specifying the position of functional group, that is, if it is one is on the first carbon, the other one is on the fifth carbon atom. So the name of this compound is 1,5-pentane dial. Next we'll be taking another cyclic compound, but here the functional group is not an aldehyde, it is a ketone. Here you can see the ketonic functional group, but the ketonic functional group here, this carbon can be included in the chain, because you can see it is a cyclic part, but the ketonic carbon is actually the part of cyclic alkyl group. So in that case, it's not a difficult one, just count the number of carbon atom in that main chain. So this carbon atom, that is the carbon atom of the functional group, that carbon atom is the first carbon. Now the two ways we can count, either in this direction, that is either in the clockwise or in the anti-clockwise direction. So when we count it in the clockwise direction, this was the first carbon, this one is second, and this is third. So on the third position will be a substitute. But if we start the counting in the anti-clockwise direction, then this one is the second carbon, third carbon, fourth carbon. So now we'll be getting the fourth carbon for the substitute methyl group. So which is closer here? That is the nearest is the third carbon. So we have to, the correct way of counting will be this direction, because here it is getting the number third. So 3-methyl, that is the substitute. Here methyl is the substitute, and the functional group here, that is an ketonic group is the functional group. So what will be the secondary suffix? That is actually the functional group for ketone is represented by suffix one. So the name of this compound is 3-methyl, and cyclo word we are using because it is a cyclic part, having how many number of carbon atom? 1, 2, 3, 4, 5. It's a pentagon. So pentane, and the suffix one. One is the suffix used for which group? For ketonic group. So this is the name of this organic compound. Next example. In this example, again there is a functional group, that is a ketonic group is a functional group. So here the number of carbon atom which can be taken in the chain, in the main chain, because here alkyl part is also attached to ketonic group and the phenyl part is also attached to the ketonic group. So the main chain should be taken, the alkyl part should be taken in the main chain. So at the time, which one will be the substitute? The substitute will be the phenyl will be a substitute. And which one is the functional group here? The functional group is the ketonic group. Ketonic group is the functional group which is included in the main chain. So how many number of carbon atoms are there in the main chain? That is 1, because this carbon atom is the first carbon now. This one is the second, this one is the third. So here the 3 carbon atoms are in the main chain. Therefore the word root is prop, and the primary suffix is an, because all carbon atoms are bonded by single bond. That means carbon-carbon bond is single. Therefore, we will be using the primary suffix an. So, how we name the ketonic group here? We have to represent its position, because it is on the first carbon, therefore it is 1. And this, for this ketonic group, the suffix we are using on. So, the name of this compound that is 1-phenyl, because the substitute is a phenyl group and that is on the first carbon. Therefore, it is named as 1-phenyl propane 1-on. So, that is the name of this compound. Now, let us take on another example here. Here also there is a functional group, that is a ketonic group is the functional group. And when we take the main chain, in the main chain, let us see how many number of carbon atoms are there, because here these all can be taken in the main chain, including the carbon atom of the functional group ketonic. It is a main chain of how many number of carbon atom? That is 1, 2, 3, 4, 5, 6, 7. Therefore, 7 means we have to use the word root, that is hept. Now look at here, hept, and there is one substitute also. That substitute is nothing but the group methyl. That is on which carbon? Here the counting should be done where the priority should be given to the functional group. So here the functional group is on this carbon, and always we have to starting the counting from a terminal position. So this carbon is 1, this is second, this one is third, 4, 5, 6 and 7. So when you look at here, the functional group is on the second carbon and the substitute is on the sixth carbon. Therefore 6-methyl, substitute is methyl at the sixth position. So 6-methyl 2-heptanone, because the ketonic group is on the second carbon, therefore we can use 2-heptanone or heptane 2-on. That can be also represented. So the name of this compound is, that is 6-methyl 2-heptanone or 6-methyl heptane 2-on. So in the textbook some examples are given, that is having both the ketonic group and the functional group aldehyde. So in that case the more priority should be given to the aldehyde group. In this example one ketonic group is also there and one aldehyde group. So here more priority should be given to the aldehyde group, that is this should be given more priority. So what will be the number of carbon atoms here in the main chain? When you count it here, that is first carbon is this one, then this is second, this one is third, 4, 5. So total 5 carbon atoms are there. Therefore the word root is pent. And all carbon atoms are bonded by a single bond, therefore ane, and the functional group aldehyde, therefore al. But here there is a prefix that should be used here, as the ketonic group should be taken as a substitute. So when it is taken as a substitute, so we have to represent it by a prefix, that is oxo, and the position is, it is on the third carbon, because this one is the first, this is the first, then this one is the second and this one is the third. So for 3-oxopentanal. The next example, in this example there is only one functional group, that is ketonic group. So we have to select the longest chain. Longest chain is of 5 carbon, 1, 2, 3, 4, 5 carbon, and 2 substitute, that is 2-methyl group that is on the second and fourth carbon. Therefore 2,4-dimethyl pentane 3-one. Look at here the position of ketone group, that is on the third carbon. So 3-one. When any substitute is there on the benzene ring in which there is a functional group aldehyde, so here because the aldehyde group and the benzene ring together, it is named as benzaldehyde. And a substitute, a nitro group is present on the fourth carbon. Why it is fourth? Because aldehyde group is on the first carbon, so the opposite position, that is the fourth position. So 4-nitrobenzaldehyde. Now the last example which is given here, when there is a 3-aldehyde group. There is a 3-aldehyde group. 3-aldehyde group. At the time we have to, instead of saying dial, we have to use the word that is carbaldehyde. So if 2 aldehyde groups are there, then we can directly include that in the main chain and we can name it with the suffix al, that is dial. But when the 3 aldehyde groups are there, in that case also we have to name it like a cyclic aldehyde group when the aldehyde group is attached to cyclic ring. Same way here also we'll name it as the carbaldehyde. Now look at the position here. The aldehyde group that is on the first carbon. Now here the main chain. In the main chain we cannot include the aldehyde group because here 3 aldehyde group are there. So if you include these two in the main chain, at the time this aldehyde group will not be able to include because the chain should be selected, should be continuous. So in such a case, we will be not including the aldehyde group in the main chain. So here which one is the main chain here? That is only the 3 carbon atoms are in the main chain, not the aldehyde group. Once again I will make here. So which one is the main chain here? The main chain, these 3 carbon atoms should be in the main chain and these 3 will be taken as name, that is tricarbaldehyde. Why it is tri? Because 3 aldehyde groups are there, that is this is on the first carbon. When we name this one, this is the first carbon, this is the second carbon, this one is third. So one aldehyde group is on the first carbon, one is on the third carbon and one is on the second carbon. So we name as propane 1,2,3 tricarbaldehyde. So to give identical treatment to all aldehyde group, the compound should be named as above, that is carbaldehyde. Now we'll be doing a textbook in-text question based on the naming. Already the name is given, we have to make the structure. Here the IUPAC name are given, we have to make the structure. So let us do this one by one. First, if the name is given to us, how we can make the structure? First start with the word root, that is prop. Prop means 3 carbon. So you make 3 carbon as it is given. And here it is represented, that is methoxy is represented, that is alpha position. Alpha position means it is the functional group is attached to that carbon is alpha position. So here the aldehyde group is the functional group, so it is attached to which carbon? This carbon. So on that carbon there is a substitute, that is methoxy. OCH3 is called as methoxy because CH3 means methyl group, and if there is one oxygen then it is called as methoxy. So here instead of numbering it is given alpha, that means alpha methoxy means it is on the alpha carbon. And which one is the alpha carbon? Where the functional group is attached, that carbon is alpha. So that means this carbon is alpha and the methoxy group is attached on the alpha carbon. So here it is ending with the name aldehyde. So that means first carbon should be an aldehyde group, that is the first carbon, this is the second carbon and third carbon. So this is the right structure for this name. Next one, that is 3-hydroxybutanol. 3-hydroxybutanol. In this case, as the but word is representing, that is the word root. So always when you are making the structure with the help of a name, first you write the number of carbon atoms involved in the main chain. That is the word root, that is but. So make the 4 carbon, 1, 2, 3, 4 carbons you have made. And butanol, null means there is an aldehyde group. So from that, one of the terminal group, just make it an aldehyde group, that is C double bond OH. Now look at here, 3 hydroxy, that means hydroxy group is present, that is on the 3rd carbon. Now which one is the 3rd carbon? Because once you have chosen this one as the aldehyde group, so that should be the 1st carbon, then this is the 2nd, this is 3rd, this one is 4th. So the OH group, that is a substitute, is on 3rd carbon, therefore it is a 3-hydroxybutanol. So just need to write the 4 carbons and keep the 1st carbon as aldehyde, that is given here. And after the keeping the number of 4 carbon atom, keep one of the carbon atom, that is a aldehyde group, and count from here 1, 2, 3. So on the 3rd position hydroxy means you have to keep OH on the 3rd position, and rest of them you have to, on the basis of the valency, that is tetravalency, you have to keep the correct number of H. The 3rd example that is given, 2-hydroxycyclopentane carbaldehyde. So it is used carbaldehyde word, that means cyclic compound, and the aldehyde group is attached to cyclic compound when we use the word carbaldehyde. And here cyclopentane, that means you have to make 5 carbon cycle you have to make, that is you have to make a cyclic pentagon. Now look at here, carbaldehyde word is used, that means here you have to add one CHO, you have to keep one CHO attached to the cyclic part. Then 2-hydroxy, there is another functional group, that is alcoholic group, but here aldehyde group is more prior, therefore we have to use the substitute, you have to use as substitute this group, that is hydroxy, that is the OH group. OH group is on the 2nd carbon. Now which one is the 2nd carbon? This we have decided as the 1st carbon. So 2nd carbon can be this, or one more possibility this. So any one of this place you can keep OH, that is the correct structure. So in this example that is given here in this answer, the OH is kept on this carbon. But instead of keeping this OH, if you are keeping OH here also, that is also correct. Next, in this one, the word root is pent, that means 4 carbon, 1, 2, 3, 4 carbon. So the main chain having the 4 carbon, because the word root is given pent. So the word root is given pent, that means the number of carbon atoms should be 5 in this. And what about the functional group here? It is given pentanol, that means functional group is aldehyde group, and that should be on the terminal position. So if you want, you can keep here or here, it's not a problem, it will be the any of the terminal position. And what about the ketone group? That is also here, one ketone group is also present here, but that is not be taken as the functional group, because aldehyde group should be given more priority. Therefore here the prefix can be used for representing the ketone group. So what is the position for here? Because the aldehyde group, that carbon should be given as priority, so that will be number 1, then this will be 2, 3, 4 and 5. So that means on the 4th carbon there is a ketone group which is represented by prefix oxo. Therefore 4-oxopentanol, where the nol is representing the aldehyde. So this is the structure for this name. 5th one, di-secondary butyl ketone. Secondary butyl means here the alkyl group, which is, that is the secondary butyl group, that is butyl means 1, 2, 3, 4 carbon. 4 carbon group, but that are not in one chain. It's a secondary, because when you see here, it's a secondary carbon. So this is 2 secondary butyl groups are there and ketone. Therefore 2 secondary butyl and 1 ketonic group at the center. Then it is the structure for this one. But this name is not called as a IUPAC name. It is called as a common name, that is given the name disecondary butyl ketone. But an IUPAC name, how we can represent the IUPAC name for this one? You have to choose the main chain, that is the main chain should be selected like this, and ketonic group is, because from both the side equal number of carbon atoms are there, that is 1 2 3 4. This is the 4th carbon, that is the 4th carbon is this one. So here 4th carbon ketonic, and the number of the carbon atom in the main chain, that is 1 2 3 4 5 6 7. 7 means hept. So we have to use hept, and ketone are there, so heptane 1 2 3 4. On the 4th carbon there is a ketonic group, so hept 4-one, and there are 2 substitute, that is methyl group, that is on the 3rd and 5th group, that is 1 2 3, and this is on the 3rd position and it is on the 5th position. So 3,5 dimethyl hept 4-one. So this is the name for this compound. Last one, that is also a textbook. It is a part of textbook in text question. 4-fluoroacetophenone. We have to make the structure for this one. Acetophenone means CH3CO. CH3CO group is called as aceto group. And here phenone word is used. Phenone word is used means there will be a benzene ring. So the benzene ring, and on the benzene ring there is a group, that is fluoro, on the 4th carbon. So here this is fluoro, you have to attach on the 4th carbon, and this is taken as the 1st carbon, and on that carbon we have a group, that is the acetophenone. So what is the structure for acetophenone? When you remove this F, now this is the structure for acetophenone. But when you keep that F, then it becomes 4-fluoroacetophenone. So these are the some important IUPAC naming and its structure. So it is important for the exam, because usually we'll be getting any one of the structure and its name you have to give. So just recall all the rules which we have discussed last year and solve the other problems related to naming in this chapter. So this is all about this video. Have a nice day.